This is a quick video on function notation, what it is and why we use it. So imagine if, in math classes, you're going to get to a point where we're not just considering one function or one mathematical relationship at a time. There's problems that require you to balance multiple mathematical relationships at one time. So imagine this. Imagine a scenario where you got a problem where this mathematical relationship, y equals x to the third, imagine that's relevant, and y equals x squared, right? Imagine you're working on some mathematical problem that requires you to consider both of these mathematical relationships. Without having some sort of naming convention, you can't easily communicate which mathematical relationship you're referring to in a particular moment. So if I'm saying, hey, if I'm trying to communicate to somebody that this mathematical relationship is relevant for a particular section of a problem, of a wider problem that we're working on, I need to be able to call this relationship out by name. That way, the person I'm communicating with, they know that I'm talking about the y equals x squared relationship rather than the y equals x to the third relationship. So in order to do that, we use what is known as function notation. Function notation allows us to name a specific mathematical relationship, and it allows us to specify what are the inputs, the independent variables of that mathematical relationship. So this is what we would do if I needed to consider the mathematical relationship y equals x to the third and y equals x squared, and I want to distinguish between them. Instead of saying y equals, instead of saying y equals, what I would do is I'm gonna get rid of this. Instead of saying y equals, I'm gonna call this one, I'm gonna call y the x to the third relationship, I'm gonna call that f of x. So I'm gonna say f of x equals x to the third. And instead of having y equals x squared, which I had before, I'm going to call that mathematical relationship g of x. So I have g of x equals x squared. And now I can distinguish between these two functions. Now I know which mathematical relationship I'm referring to in any particular moment. If I want you to consider the x squared mathematical relationship, I would say g of x. I would say focus on g of x or use g of x. And then if I want to consider the mathematical relationship y equals x to the third, I can just say f of x. Another reason, so that's one benefit of function notation. That's one need. That's why we use it. Another necessity of function notation is to identify your inputs. What are actually input variables and what is a coefficient? So let's say I got the function, x squared plus t y equals, let's say I got the equation y equals x squared plus t. How do you know which one of these is a variable versus which one is or actually, I won't use this one, right? You all are used to seeing x as a variable. I'll do something that you may not be so used to. What if I say c equals a squared plus b? How do I know, right? Just looking at this expression, how do I know if C is a variable or a constant, or if A is a variable or a constant, or if B is a variable or a constant? There's ambiguity here. It's ambiguous. We don't know if these letters are symbols that represent variables of a function, of an equation, or if they're symbols that represent constants. So what function notation allows us to do, it allows us to remove that ambiguity, remove that confusion. So instead of having C equals A squared plus B, right? I know in my mind, as the person who created this equation here, I know in my mind that A is meant to be a variable and B is meant to be a constant. So how do I communicate that? I communicate that with function notation. I'm gonna, instead of saying C equals A squared plus B, I'm gonna say, I'm gonna label this. I'm gonna label this this function C of A. So rather than just calling it C, I'm gonna call it C of A. And what that does is now it's clear. It's clear what the name of this function is, this mathematical relationship. And it's clear what the variable is, what the independent variable is. A is my independent variable. And so B is a constant. And now I know that. Now I know that thanks to function notation. Now, what if I wanted to say B is the independent variable and A is the constant? Then what I would do is I would change this function. It wouldn't be called C of A, because when you call it C of A, that implies that your independent variable, your input variable, is A. So if my input variable, my independent variable, was B instead of A, then I would call this C of B. And then I would know that B is my input variable, A is a constant, because function notation helps me distinguish that. So the two main reasons for function notation, one is so that you can assign a name to a specific function. In order for us to be able to talk about things, we need to give them names. In order to be able to discuss concepts and ideas, we need to assign names to them. So function notation allows us to assign names to mathematical relationships. And then the second thing that it allows us to do, it allows us to quickly identify what the independent variable, or AKA the input variable, is. It allows us to distinguish between what's an input variable versus what's a constant that just looks like a letter. What's a constant that's being represented by a letter. Functions can have multiple input variables. A function doesn't just have to have a single input variable. This function here, we can say both A and B are input variables. The way we could specify that, so let's imagine that A squared plus B. I don't want that to be, I want it to be known that A squared plus B, neither one of these are constants, right? Neither one is a constant. Both are variables. Then what I would do is I would say C of A comma B equals A squared plus B. And now what I just communicated, when I call this mathematical relationship C of A B rather than C of A or C of B, what I'm saying is both A and B are variables. Both of them are going to vary. This is useful, especially as you move up in your mathematical careers, It's not always going to be the case that your functions have one variable. In fact, the higher you go in math, the less likely you are to get a single variable function. The functions mostly have multiple variables. So, yeah, that's it.